Hi everyone and welcome back. In this video, I'm going to continue the example from a previous video establishing an inheritance relationship between a pet and an animal. So let me show you where we left off in that video. We have this animal-based class that has two attributes, a species such as a dog, a cat, a tiger, a hippo, etc., and an age such as like 1-year-old, 10-year-old, etc. So animal is a base class for the pet-derived class, and I make that relationship here, stating that pet inherits from animal. You can see the pet-specific part of a pet is that a pet has a name, right? So any old animal doesn't necessarily have a name, but a pet has an owner, and an owner gives a pet a name. So this is what makes a pet a more specific version of an animal. I went ahead and made another subclass of animal in between the last video and this video called wild animal. So wild animal also inherits from animal, but a wild animal, unlike a pet, doesn't have a name. But if it's out in the wild, then it does make a ferocious noise, such as roaring or growling or hissing, etc. Hopefully you think my little animal, pet, wild animal inheritance hierarchy is kind of fun, because now we've got a wild animal that makes ferocious noises, but we've got a pet that doesn't. It just has a nice name like Fido. All right, so let's head over to main.cpp and just refresh where we left off, and then we'll make a few wild animal objects. And in this video, we're going to talk about polymorphism. So we ended with an animal pointer and a pet pointer, and we were discussing static versus dynamic binding. So static binding is when the compiler figures out at compile time which toString to execute when we have an animal pointer that, say, points to a pet. Okay, so before we made toString virtual, we would get the animal execution of toString. But once we headed over to animal.h and we changed the toString for animal to be virtual, at runtime we were getting dynamic binding instead of static binding, where the compiler was waiting to figure out which toString to execute until runtime, where APTR was referring to either a pet, in which case pet's toString was executing, or referring to an animal, in which case animal's toString was executing. So that's how we got this behavior down here, where we were getting the pet-specific implementation of toString to execute because we changed toString to be a virtual member function. All right, so that's just a quick review of static versus dynamic binding. And you're probably wondering, well, why do we even need dynamic binding? Well, dynamic binding, along with pointers and references, enables polymorphism, which is another pillar of object-oriented programming. So that means it's really important, and it's really cool, actually. So before we start on polymorphism, let's just make a few wild animal objects, and then we will use them as part of a pretty comprehensive polymorphic example. So I'll just do a default value constructor here, make sure everything's working right, and then you can see the ferocious noise in action. Maybe we'll make a tiger as well. I need to compile this with wildanimal.cpp now because I'm including it, the header file for it in main. Okay, so here's our output from the lines of code I added down here, lines 43 through 46. So we're invoking the default value constructor for animal, and then the body of wild animal default value constructor, and here we're seeing the toString for that default value, WA animal object right there. And then I'm making a tiger wild animal using the explicit value constructor. So we see the EVC for animal executes, and then the EVC for wild animal executes. And then we see a 2-year-old tiger that goes roar. All right, so let's start talking about polymorphism. So what I'm typing right here is a little note on my really shorthand definition of polymorphism that I always keep in the back of my mind when I think about polymorphic behavior. So polymorphism, if you look at kind of the roots of poly and morph, this definition makes sense. Same code, different behavior. Okay, same code, different behavior. Right? So poly, many, morph, to change. Same code, different behavior. Let me read a very textbooky definition for polymorphism, and then we'll come back to mine. We'll do an example, and hopefully between these two definitions, you're feeling pretty good about it. All right, polymorphism allows an object reference variable or an object pointer to reference objects of different types and to call the correct member functions depending upon the type of object being referenced. All right, that's pretty long, but we will break it down. So with a pointer or a reference to an object, we can call a virtual member function to get object-specific behavior at runtime, even if the pointer or reference is of a more general type. So I'll say, for example, in here, superclass, such as animal. All right, so let's see the example that we're going to work with for polymorphism. We've already seen a little bit of polymorphic behavior up top here when we were working with this APTR, which was a generic animal pointer, and we had it point to an actual pet object in memory. When we changed toString and animal to be virtual, instead of getting static binding, we got dynamic binding, which allowed us to get that pet-specific output here, where we were seeing the toString for pet being executed instead of the toString for animal being executed. Now we're going to do that example kind of on steroids, and we're going to have an array of animal pointers. So some elements in this array will point to animal objects, some will point to pet objects, and some will point to wild animal objects. We will call toString in a loop for each pointer. Because toString is declared as virtual in our parent class with dynamic binding, we are going to get different behavior, e.g. Animal, pet, or wild animal specific toString with the same code. Simply animal PTR toString. All right, so let's try it out. So here's going to be my array of animal pointers. So I'll call it animal PTR array. Let's just have 4. We'll keep it kind of small. So animal PTR array sub 0, we'll just make it store, say, A. Sub 1, we'll have it point to, say, my pet. Sub 2, let's have it point to, say, tiger. And then animal PTR array sub 3, let's have it point to, let's see, where was our other one? Let's do D. That's where we created an animal using the explicit value constructor. All right, now we're going to walk through and get a pointer to each one of these pointers in animal PTR array. And we're going to print out toString using that pointer. We'll have the same code in the loop, but we'll get different behavior depending on what type of object that pointer actually points to. So I'm going to have animal star, I'll call it animal PTR for each pointer in animal PTR array. And I'm going to do animal PTR. Use our arrow operator in order to dereference and invoke. We'll call toString. All right, so here's our output from our for loop because we have 4 animal pointers in it. So it's going to execute 4 times. All right, so remember, we've got animal, pet, wild animal, animal. Okay, those are what our animal pointers actually point to in memory. So you can see we're getting toString executing specifically for what type of object our general animal pointer actually points to. So here we're just getting the general animal toString. Here we're getting the pet specific toString. Here we're getting the wild animal specific toString. And here we're getting the general animal toString. Okay, so back to my definition of polymorphism. Same code, different behavior. Line 61 is using an animal pointer to dereference and select the toString member function to invoke it. This is the same code for all of those different animal objects that are pointed to in the animal pointer array. Same code. But at runtime, we are not getting 4 executions of animals toString. We're getting an execution of animals toString, an execution of pets toString, an execution of wild animals toString, and then another execution of animals toString. Okay, this is really important. This is different behavior, right? The same code is giving me different behavior at runtime, and that's what polymorphism is. So I'm going to read the textbook definition again one more time, hopefully after seeing this more comprehensive example with dynamic binding, you're going to understand a little bit more about polymorphism. All right, polymorphism allows an object reference variable or an object pointer to reference objects of different types, okay, like animal, pet, and wild animal, and to call the correct member function, like toString, depending upon the type of object being referenced, like animals toString versus pets toString versus wild animals toString. All right, with that, I will conclude this video with more details about how virtual and dynamic binding works in terms of this really large concept in object-oriented programming called polymorphism, where you can have same code like we have here, give you different behavior at runtime. All right, thank you for watching.